Okay, so I'm going to do this lab. I'm going to collect data for you, and let's see how fast I can do this so the video's not too long. I'm going to try something new. But here's the idea. We're going to take some coffee filters and drop them. And the difference when you drop a coffee filter versus something else is that it doesn't accelerate the whole time it falls because there's an air resistance force on there. So let's imagine that I take my coffee filter and I let it go. Right when I let go, it has one force acting on it, the gravitational force mg. So that means it's going to accelerate down. But now, a little bit later, it's moving with some velocity in that direction, and it has the same gravitational force. But now there's an air drag force pushing up also. So when you push, you can feel see that? You can feel the air if you do this. That's the air resistance force. It depends on a couple of things. It depends on how fast you're moving. It depends on the size of your object. And it depends on the density of the air. So we're going to model the air drag force as though it was just equal to the magnitude of the air. It's going to be some constant c times the velocity squared. So that means that as this thing speeds up, this air resistance increases. Now eventually it's going to get down here so that it will keep speeding up until the air drag force is equal to the weight, and then it will move at a constant velocity. We call this terminal velocity. So at terminal velocity, Fa equals mg. So I could say, if I use this, c v terminal squared equals mg. That's true at terminal velocity. That's very important. So what we're going to do is a couple things. Number one, we're going to measure the terminal velocity for different objects. And the nice thing about these coffee filters is that I can stack them and it doesn't change the drag coefficient c. Because I'm not changing the size, I'm not changing the shape, it doesn't change anything. But by stacking them, I can change the mass. So I can change the mass and get a new terminal velocity and make a graph. So that's what we're going to do. So I'm going to go ahead, I've already found the mass of this stack. I don't even know how many there are. And it's 4.9, I'm going to write that up over here. 4.39 grams. I'm going to measure the terminal velocity, and then I'm going to take one out and I'm going to do it again when we get a bunch of data, and then you can make a graph, and you can see if this is indeed true. What should you plot to make a line, a straight line? In this case, we're changing the mass, and we're measuring the terminal velocity. That's something we've practiced before. I want you to practice it again. And then what's the drag coefficient? Okay, so I'm going to use this. I think we've used this before in class. This is a motion detector, so it sends out a pulse of sound. That sound reflects off stuff and comes back, and it times how long it takes to do that. So in this case, I'm actually going to put this on the floor and drop the coffee filter on top of it so I can get the motion. Okay, let's get started. I'm going to go ahead and pull this down. Let's see if this works. And then I'm going to turn on the projector. Turn on the projector. Look at that turned on. And then that way I can project my screen up here, and that way you can see everything, right? It's going to be awesome. Okay, so I have that plugged in. Shows up. Let's just move this to the window. There we go. I've already started practicing to make sure it works. So it's going to plot position versus time and velocity versus time. And I'll actually show you how you can use both of them. And then I'll record the data. So let's go ahead and clear the data, because I don't really want that. Experiment, clear latest from. Can you see that okay? Let me check. I'm trying to see if I should turn off the lights. I think it's okay. I'm going to leave it. Okay. So I have my motion detector. I have my coffee filters. I'm going to be right here. And if I fall, it's going to be on camera. And I'm going to drop it. Like that. gonna be great. Okay. So go up here. Oops. Doesn't want to collect. There it is. Okay. Oh, it did work. Okay, so it didn't show it. Okay, that's pretty good. You see right here that it started off at 2 meters above, and then it started speeding up because the slope changed. But down here, the slope's fairly constant. Let's just use a position time graph. I kind of like it better. And I'm going to just make this bigger. So now all I need to do is find the slope of this part of the graph. I'm going to go up here, click slope. Okay, so that gives me a slope of 2.654 meters per second. So I'm going to write that over here, and I'll take a picture of this. 2.654. Now, we should do it again multiple times and get uncertainty, but we're not going to do that, okay? Because I don't have time. So I'm just going to do the next number of coffee filters. So I'm going to take this off. I can take one of these off. And I don't even know how many there are. So now, one removed. So I have a new mass. I don't know what that is. We'll find that out at the end, and I'm going to drop it again. Okay. So, click. Oh. Erase and continue. Okay, so now you see, I just need to move my little line down here. And I get 2.197. And now I'm going to do it again. I'm going to take off another coffee filter. Hopefully I have enough. I have at least 3. And I'm doing it this way so I don't change the shape. If I take them and stack them, they don't work as well. Okay. Right. Okay, I'm just going to go ahead and clear the data. Experiment, clear latest, run, now ready. Oops, sorry. Okay, excellent. Move this right there. .828. 1.828. Okay, now I'm going to take off another coffee filter. Okay, now that was 3. So I can put down here 3, 4, 5. So that's how I know. Because now I have 2 left. Clear latest run. Okay, and then just move this down. And I get 1.593. And then I'm going to do 1. Yeah, that one. Actually, I want to save this one. Because let's put this, because this is important if you want to do something. I'll just take a screenshot of this. Now, I'm going to go up here and inspect. Because look, I let it go right here, okay, at 0.45 seconds and 2.068 meters. So let me write that down because that's going to be important. So T equals 0.45 y equals 2.068. And then that's T1, Y1, T2, and Y2. I want to get the values at the bottom. And this, just in case you want to build a numerical model, this will be very useful. So down here, it's at 1.4 and 0.987. Okay, so drop about a meter, that's fine. Okay, so we can use that. Now I'm going to go over here and do my single coffee filter, experiment, clear latest run. We're ready to go. And let's see, okay, these little spikes right here, so it just didn't get a good reading on the coffee filter. But down here at the end, it looks like it did. I think it's enough for us to get data. So I'm going to pull this down here. Pull this over here. And I get 0.952. So that's pretty good. So 0.9528. Okay, so you can get the mass of all these things. We have the velocity, and that's enough to make the graph. Now, if you are challenging yourself, if you want to do a lab report, one of the things you could do, let me turn this off, is to model the motion of a falling coffee filter. Okay, because if you remember back before we had this numerical calculation, oh, it didn't turn off. So I know these forces right here. I can calculate F. Chalk's terrible. Let me do it over here. F net equals, it's going to be this force, C V squared, and this is in the y direction, minus mg equals ma. So I can find the acceleration. And then if you remember when we did the numerical calculations, once you know that acceleration, I can use that and say V2 equals V1 plus A delta T. If I break it into a small, tiny time step, I can assume the acceleration is constant and find the velocity at the end. And then I can use that velocity and find the new position. Y2 equals Y1 plus V2 delta T. And then I can just go back up here and do it again. Okay, and you keep on doing it. You can model the motion of a falling coffee filter numerically. Now, once you do that, you would use your drag coefficient that you calculated from your graph, but you'd want to check it with some real data. And that's what this, I don't think you can even see it. I'll take a picture of it. This data for one coffee filter, or that was two, I'm sorry. 2 coffee filters, you could use to make sure that your model at least kind of works. Okay. So I'm going to post this video. I'm going to post a picture of the data and that data over there too. And then you should have enough to make a graph. And that's what I want you to put for your quiz. I'm going to quiz thing where you submit your graph. Okay, cool. I think hopefully that should work. I'm going to turn this off now. If you guys have any questions. Oh, if you have any questions, you can come. Remember, Group A can come to the first half of the class. Group B can come to the second half of the class.